Hey class! In the last lesson, we kind of talked about what are acids, what are bases, and how do we find their conjugate acid and base. But now we're going to focus on what if we have a solution and we're trying to figure out if it's considered acidic, basic, or neutral. So this idea of concentration was actually brought up last semester, and we learned that concentration is measured in something called molarity, which is represented by a capital M. And we said that molarity stood for the moles of solute divided by liters of solution. Well, one thing to take away, and one thing I really want you to understand, is that we do not like to say concentration every single time. We don't like to write it out. So sometimes you might see things be abbreviated. So sometimes you might see things in brackets that say H plus. The brackets mean the concentration. So this is H plus concentration. Or if I put, let's say, hydroxide, this is the concentration of hydroxide. So again, we use brackets to say concentration. To understand whether something is acidic, basic, or neutral, we have to realize how did we get our neutral point or our middle point. And we're going to talk about something called the auto-ionization of water, which means that water gets ionized automatically every single day. And this is because it is one of the most important chemicals that has a lot of different ranges. And one of the different ranges is its ability to act as either a Bronsted-Lowry acid or a Bronsted-Lowry base. Couple things to review is those two definitions. Based on the definition, if you are an acid, you act as a proton donor. In other words, you donate an H plus ion. If you are a base, you are a proton acceptor. This means, again, you are accepting an H plus ion. Also remember, when you are a donor, you are giving away, so you're becoming more negative, whereas you're an acceptor, you're going to accept a positive charge and you become more positive. So what do I mean by this auto-ionization of water? One thing to understand about water is that whenever you have a cup of H2O, it's not always exactly pure H2O. Water can actually act as both an acid and a base, and we call this amphiprotic. One water molecule can actually donate a proton to another. And like we said, this is called auto-ionization of water. So here in the image below, I have two waters. Essentially, this water is going to lose a hydrogen and become hydroxide, where this water is actually going to gain that hydrogen and become hydronium. And then you're going to also hopefully notice that this is not a single arrow right here. This is a double arrow. And this means that this equation is an equilibrium. It means as much as water is turning into hydronium and hydroxide, hydronium and hydroxide is turning back into water. And this process is continuously happening. We call this point equilibrium, and that's usually what we mean by those double arrows. As much as the products are being made, they're being reversed and they're going back to reactants. And this allowed us to make an equation known as an equilibrium constant that we are going to use this entire section, and then we're going to be using in future lessons. So the equilibrium constant stands for Kw, and the equation is as follows, and this one is the most important equation you're going to use today on your homework. Here we have H3O plus in brackets, and that means the concentration of hydronium, times the concentration of hydroxide is always going to equal 1.0 times 10 to the negative 14th. One thing I want you to remember is that H plus and H3O plus are the same for our intended purposes, which means sometimes you might see this equation written as H plus times hydroxide equals 1.0 times 10 to the negative 14th. And again, they mean the same thing for our purposes for this lesson, so you can see them, same thing. So we have to bring about this idea. When we have that equation, what does it mean when something's neutral? And then we're going to talk about what does it mean when something is acidic or when something is basic. So a solution in which my hydroxide equals my hydrogen ion is going to be neutral. Sometimes you might see these rewritten as H3O plus is equal to OH negative. Again, same thing. Now, when we say that my hydrogen concentration equals my hydroxide concentration, how do we actually calculate what those values are? So here we're just going to look a little bit of math. If my equation is H plus times OH is always going to equal 1.0 times 10 to the negative 14th, and these have to be equal to each other. Essentially what you're asking is what times itself is going to equal 1.0 times 10 to the negative 14th. Essentially, you can also say that x squared, because whenever you square something, you're multiplying it by itself, equals 1.0 times 10 to the negative 14th. And then we just have to get x by itself. And the easiest way to do that is to square root it. And so if something is neutral, you're going to see that its concentration is going to actually be 1.0 times 10 to the negative 7th molarity. Again, if I ever say a solution is neutral, that means both the hydrogen concentration is equal to 1.0 times 10 to the negative 7th, and the hydroxide concentration is equal to 1.0 times 10 to the negative 7th. However, hydrogen and the hydroxide concentrations are not always equal, and this is where we get some things that are acidic and then some things are basic. One thing to take away is because we have this equation of H plus times OH negative equals 1.0 times 10 to the negative 14th, because we have this equation, this 1.0 times 10 to the negative 14th cannot change. It will always be that number. And so whenever you adjust one of these concentrations, it's going to affect the other. And they have an inverse relationship. If one of these increases, that means the concentration of the other has to decrease. Again, because they are always going to equal 1.0 times 10 to the negative 7th. So based on this concentration, we can say if something is going to be acidic or basic. So here, if my H plus concentration is bigger than my hydroxide concentration, we are considered an acid. And here it says with numbers if your H plus is actually greater than 1.0 times 10 to the negative 7th. Now, negative numbers tend to confuse people when we're talking about less than or greater than. So what that means is if you are an acid, you are typically going to have an exponent that is bigger than negative 7. This means numbers like negative 6, negative 5, negative 4, negative 3, negative 2, and even negative 1. Yes, you will get negative numbers. You will not be working with positive numbers here. If you are basic, it's going to be the opposite. It means that your H plus concentration is actually less than your hydroxide concentration. In other words, to be basic, your hydrogen concentration, and notice here it always says hydrogen, we're always going to use hydrogen, is less than 1.0 times 10 to the negative 7th. When I say negative 7 and things that are less than it, that means you're looking for exponents like negative 8 or negative 9, negative 10, negative 11, negative 12, negative 13, and negative 14. You will not have anything that is less than negative 14 because you have to equal negative 14, so you can't have negative 15 or anything like that. So here we're going to look at these solutions and tell me if they are neutral, acidic, or basic based on the exponent. Notice here we're always using H plus to identify if they're neutral, acidic, or basic. We don't care about any other concentration but my hydrogen. Here we have a -9. So if we actually go back to the previous slide, -9 is less than -7. So here we have -9. If we are less than, you are actually considered basic. So here we're going to classify this concentration as basic. Here, 1.0 times 10 to the -7th. If you go back on the previous chart, well, in order to be an acid, you have to be greater than that number. If you're basic, you have to be less than. So if you are actually exactly a -7, you are considered what we said right smack in the middle, and you are considered neutral. Then on the last one, 7.0 times 10 to the -3, again, we're going to look at this -3 value. And we have to ask, is it bigger or less than -7? Well, -3 is actually greater than -7, and here we have it written. We see this -3 over here, and that means that you are acidic. Now, exponents can trip people up because we are working with negative numbers, so you might be like, wait, that doesn't make sense. 3 is less than 9, but again, we're working with negative numbers, so -3 is actually bigger than -9. From there, we're going to actually use this equation not only to tell whether something is acidic or basic, but you can actually use it to calculate and do math. Remember, if we take my hydroxide times my hydronium, or remember, hydronium is the same thing as saying H+, again, same thing. This is always going to equal 1.0 times 10 to the -14th. That means we can use this as an equation. If we know one of them, we can actually solve for the other. For example, if I know the hydrogen concentration, I can solve for the hydroxide. And that's exactly what we're going to do. Here we are given hydroxide concentrations, and we're going to actually calculate the hydrogen concentration. Before we do that, I'm actually going to just write the equation up here. And this is going to be the one that we're going to use. Here, we're just going to plug in what we know. So it says calculate the H+ concentration. So we do not know that. So I'm actually going to plug that in right here. We're going to multiply that by the hydroxide concentration, and it tells us that our hydroxide concentration is 0.010. And then it says in our equation, this always has to equal 1.0 times 10 to the -14. From there, we're just going to use our basic algebra skills, and we are going to solve for x, or solve for H+. In order to do that, we're going to divide by the number that's attached to my unknown. So we're going to divide by 0.010. And when we divide by 0.010, we actually get the answer of 1.0 times 10 to the -12. Couple things to point out about this answer. Your calculator might say 1 times 10 to the -12, and I wrote it as 1.0 because here I have 2 sig figs, so I need 2 sig figs in my answer. The other thing I want to point out is that we are finding the H+ concentration. So because we're finding a concentration, we have to make sure that we include the unit molarity. Again, this is my H+ concentration. Now, if I were to ask you whether this solution is acidic or basic, we can still use the same rules that we used on the previous slide. Again, if you are asking if something is acidic or basic, you need to look at its H+ concentration. So here it says H+ concentration is -12. -12 is actually considered basic because -12 is less than -7. We can actually solve for this other problem as well. We're going to set it up the exact same way. We don't know my H plus concentration. We are given my hydroxide as 1.8 times 10 to the negative 9, and this is always going to equal 1.0 times 10 to the negative 14th. Here, we're going to make sure that we divide by the number that is attached to my unknown, so 1.8 times 10 to the negative 9. And when you solve for this, you will get 5.6 times 10 to the negative 6th. Again, 6. I'm going to use 2 sig figs because I have 2 sig figs here. And I'm going to make sure that I put molarity, my unit, on there as well because we are finding concentration. A couple things to note is that because we are working in scientific notation, please make sure that when you are putting this in your calculator, you're putting parentheses around it, because if you don't, you're not going to get the correct answer. So make sure that you're doing that. Here, if we were to actually look at this and say, is it acidic or is it basic or is it neutral, we're going to look at my H plus concentrations and we're going to look at my exponent. Here, my exponent is negative 6. So you have to ask yourself, is negative 6 greater or less than negative 7? And it is actually greater than negative 7, so this is considered acidic. Again, negative 6, if we go back several slides, negative 6 falls under the acidic or acid solution. If you have questions on this or you're getting confused, please make sure that you guys get help, because I really want to make sure you understand this because this equation we'll be using quite frequently. To end out the lesson, we're actually going to flip it now. Instead of finding my H plus concentration, you're going to find the OH concentration. Fun fact is that we can use the exact same equation in order to do this. We can say H plus times your hydroxide equals 1.0 times 10 to the negative 14th. And just like the previous problems, we are going to solve them the exact same way and plug in what we know. So we know that hydrogen is 2.0 times 10 to the negative 6th. We do not know my hydroxide concentration, and we still know that this is 1.0 times 10 to the negative 14th. Even if we were to set it up down here, same thing. 1.0 times 10 to the negative 8th times my hydroxide equals 1.0 times 10 to the negative 14th. Again, just like our problems on the previous slide, we're going to divide both of these by what was given attached to the hydroxide, so 2.0 times 10 to the negative 6th. And this one is going to be divided by 1.0 times 10 to the negative 8th. Then we're going to go ahead and solve both of these out. This one ends up being 5.0 times 10 to the negative 9th. And then this one ends up being 1.0 times 10 to the negative 6th. Again, we are using these numbers because we want to match them up with the correct number of sig figs. Do not forget your unit, which is molarity. Also, don't forget this, we are finding the OH concentration here. It says calculate the OH concentration. So that's important to keep straight. Who is the OH concentration? Because if I were to ask you who is acidic, basic, or neutral, you need to make sure you're looking at the right concentration. In order to tell me if something is acidic, basic, or neutral, you need to look at your H plus concentration. So a lot of people make a mistake and they look at this negative 9 and they tell me, oh, this is basic. However, this is my hydroxide. You need to be looking at your hydrogen. So you need to be looking at this negative 6. Because of this negative 6, it is actually considered an acidic solution. Again, because we're basing it off the hydrogen concentration. For the second one, again, we don't care about this OH concentration when we determine if it's acidic, basic, or neutral. We're going to have to look at this H plus concentration. So we care about this -8, and we say that -8 is actually, -8 is actually considered basic. So here, notice if we're finding the OH, we're going to look at our original number. Let's go back. If you're finding H plus, you're going to look at your answer because you're always going to be looking at that H plus concentration. That is the end of today's lesson. If you have any questions or you're confused at all, please make sure that you come and get help. Otherwise, I have nothing for you, and I hope that you guys have a great day.